In this video I'm going to talk about the cross product. Now the cross product of two vectors a and b in R3 is denoted by a cross b, and it's calculated as so. Here we have a determinant, so here with these vertical lines either side of this 3 by 3 matrix defines a determinant. If you're not sure what that is, I suggest you go back and watch my video on determinants. Okay, so a cross b, so what we do is we form a 3 by 3 matrix where the first row are the vectors I, j and k. Now these are simply unit vectors that point along the x, y and z coordinate axes. These are known as basis vectors. Okay, so I is 1, 0, 0, j is 0, 1, 0 and k is 0, 0, 1. Then we list the elements of A in the second row and we list the elements of B in the third row. This will give us a vector. So the cross product between two vectors returns a vector. This is unlike the dot product, which returns a scalar. Now, in terms of geometrically speaking, the cross product between two vectors returns a vector that is perpendicular to both. So imagine if we got vectors A and B. Now the cross product between A and B returns this vector, which is perpendicular to both A and B. We've also got another result where if we do B cross A, this returns a vector which is also perpendicular to A and B, but just points in the opposite direction. So this is important to note that cross product is not commutative, but if you do it the other way around, it just returns a vector but points in the exact opposite direction. So here's an example. So we're going to calculate the cross product of two vectors A and B. So we first form our 3 by 3 matrix. So the top row are the basis vectors I, j and k. The second row are my elements of A, and the third row are the elements of B. So this is a determinant. So if I block off the first row, first column, I'm left with the 2 by 2 matrix 2, 3, minus 1, 3. And if we calculate the determinant, it's 2 multiplied by 3, which gives me 6, minus 3 multiplied by negative 1, which gives me plus 3. If I block off first row, second column, okay, that leaves me with the 2 by 2 matrix 1, 3, 2, 3. So the determinant is 1 multiplied by 3 minus 3 multiplied by 2, which gives me minus 3. But remember, when we're dealing with determinants, we have to multiply, if the row number plus the column number is odd, we multiply by minus 1, so don't forget that step. And if we block off the first row, third column, we're left with this 2 by 2 matrix 1, 2, 2 minus 1, and its determinant is 1 times negative 1, which is negative 1, minus 2 times 2, which is minus 4. Okay, so this gives us 9 times the vector I plus 3 times the vector j minus 5 times the vector k. So if I write in the vectors I, j and k, and if we perform vector addition on those three, we end up with a vector 9, 3 and negative 5.